Hello guys, welcome to Inside Electronics. So in my last video I did a complete review including testing and all the drawings and everything, a complete tear down video of this particular thing right here, which is basically the advanced, or let's say this next generation of these Goodnight Active Plus Mosquito repellents. Now this one, in my last video I never took this one apart because I thought both of them will be having the same circuit inside, but after having those experiments with this particular model, I'm having my doubts whether this one is also having the same kind of circuit inside. So there is only one way to find out. Let's open up this one. By the way, the outer casing for this one, I lost it somewhere, but it just looks exactly the same as this one. The only noticeable difference is that the color of the LED is much different. This one, even when both the green and red are glowing, the green is actually not that prominent because the red one is actually overpowering the green one. Sorry for that. So if you plug this in, even when both those colors are on, only red is visible. But in this one, let me just plug this in and show you. If you plug this in, you can see it has a beautiful green color right there. It flickers because there is no filtering going on, and that's the next color right there. That's actually orange. It is orange and it is showing as orange in the camera itself. So let's take this thing apart and see what's the difference between both of these. So this is the specifications. We have already looked at that in my last video. And by the way, this is made by a company called Godrej. I don't remember when I bought this thing, and that's just spilling things everywhere now because of the SE screw. It is actually having a similar sort of circuit, and as you can already see, the construction looks similar. Let's take this out completely, and this is the bit where you hold the vaporizing liquid, and oh, it's hot. Just by plugging that in, it is already hot, and right away I'm seeing some actual differences. Not just the color. See, this one is completely covered in this black plastic, and it has the ceramic substrate that holds the actual heating element inside, which is completely covered. But in this one, the top portion is exposed and only the bottom piece is covered, and we cannot take that apart because it is sealed on that side. And to actually take that apart, you need to take this one out. And let's take a look at what are the changes in this. If you take a look, you can immediately notice that there is no thermal protection, or the thermal bimetallic strip in this one. See, and also let me just show you that is a common wire connected to one of the terminals. And if you notice, this one also has two terminals, just like these two terminals on this one, and that is a common. This one has a common and two other terminals. But notice, have you noticed this? One of the thermistor is directly connected to the AC mains, irrespective of whether the switch is in the switch position, if it up or down. One thermistor is always connected to the AC mains, and only when the switch is turned to the active mode, the bottom one is just the normal mode, as the cover suggests is the normal mode, and the top one is the active mode. So in the normal mode, what happens is let's take a look. The AC mains is coming in and that is the common, that is the 10 kilo ohm resistor for the LED. The AC mains just comes in straight through the switch, and the switch is only used to turn on this LED in the bottom position. Let me just draw the circuit diagram for you so that makes everything simple. So guys, this right here is the circuit diagram for this particular model, and as you can already see from the figure, that one of the PTC element is directly connected to the AC main C. This one is coming through here and it is connected straight to the PTC element, and that is this particular connection that one right there, the metallic pins going on. And when that one is on, when that PTC element is on, current can actually flow through this diode, which is that one over there, this one, and that one actually provide the DC current for this green LED, and that's why the green LED glows, and it passes through the 10K current limiting and goes back to the AC mains, whereby lighting this green LED. So the only use for the switch comes when the only use for the switch is to turn on the second heating element, that one. So that's how that is connected. The switch is connected directly across the AC mains input. So when the switch is flipped up to the active mode, what happens is that this one is connected, this one is already connected to the AC mains, and when you turn on the switch, what happens is that current can flow through this path and to the second PTC also. So the current will flow through both of the heating elements, which provides the additional heat, whereby vaporizing more liquid and creating more effect. And at the same time, the green LED is also always connected to AC mains, and when the second element is turned on, the red one will also activates, and both of them combines to produce that nice orange effect that you just saw before. So that is the way this particular thing works. Let me just move this away. So that is the obvious difference between these two elements. In this one, as we have already seen, the switch is what turns on the two PTC elements, and this thing plays a very important role. If you haven't watched that video, make sure you watch that video first, because otherwise you don't understand how this particular circuit works. I'm not going to explain that circuit here. So just like in my last video, let's just compare the resistance of this particular model. I'm going to put the meter in the 20K mode right there. Let's just read the common voltage, because one PTC is already connected. Let's just measure the resistance of that one. It is showing around 10.11K. Is it because of my hand? Resistance of the hand? Nope, it's showing 11K. The one that is already connected is showing as 11K. Let's measure across the common and the other heating element, which is right there. And interestingly enough, that one is only 8 kilo ohms. So there is a difference in the rating. This one, it's not, this one right here is at 11K, and the second coil is only 8K. So there is a difference in the resistance of the heating element used inside this particular model, which is not the case of this one. This one, as we already seen, is having the same how much was that, 3K. Yep, it's a 3 kilo ohm resistance. 3, I don't know, was it 3 or 4? Anyway, somewhere in that region. Both of them were of the same resistance, but in this one, the resistance are different. So let's see how it changes when we plug this thing and the element gets hot. So I'm going to plug this in right now, and let's measure the voltage after a couple of minutes. Keep in mind that this will not automatically activate the other PTC elements. You need to manually activate it using this switch. So initially I'm only going to check the resistance of the one activated hot plate, and then once it is cooled down I will turn on both of the heating element and we will measure it then. So initially I'm going to plug this in and let it heat up. Okay, now let's just wait. Okay, now this thing is plugged in for around 5 minutes now. Let's quickly measure the resistance now. I'm measuring, keep in mind that I'm actually measuring the only active element now. So it is showing around 5.6 kilo ohms. Notice that 5.8 kilo ohms. So the resistance is already coming down. The resistance is coming down just like the other one. Let's measure it once again. Okay, I just dropped everything, and that was only one heating element, and now I'm going to turn on both the heating elements, and I'm going to plug this in again and let it heat up, and we will measure the resistance once both of them are hot. Now you can see the orange one is on. Let's wait for another couple of minutes so that both the heating elements will get hot enough, and let's measure the resistance afterwards. Okay, so now this thing has been sitting here for around 6 or 7 minutes. Let's unplug it quickly and let's measure the resistance once again. I'm measuring the common resistance now. So even the tip is getting hot, and you can see the resistance is really low. It's only 1.4 kilo ohms. And let's measure the other element quickly before temperature, and that element is also at 1.4 kilo ohms. 1.4 and 1.4. So that is really strange, because they claim that these are PTC elements, but they are acting like NTC elements. Or am I completely wrong? Are they actually using an NTC? But that cannot be true, because as I said, if they are using NTC, then the current flow is going to increase when the resistance is actually, because the resistance is actually decreasing, the current flow is going to increase, and which increases the power consumption. But that's not the case here. So if somebody can explain what is happening here, that will be really good, because I don't quite understand what the exact thing going on. I guess there is only one way to find out what is causing that, is to completely destroy the heating element. That's really hot, that thing right there. So both of these are fully working, so I'm not going to destroy those, but I have a dead one right here. This 2006 version. This is a completely dead unit, so I can tear this thing out, and I will definitely take apart the heating element of this one, and let's take a look at that when I do that. So yeah, quite an interesting circuit. The circuits are obviously different now. Recently they have introduced an even updated model of this Goodnight Active Plus. If I can get one of this, I will definitely compare all of them again. I will do a complete teardown of that also if I get one of those. But until then, thanks for watching. See you in my next teardown video.